Hello everyone, I'm Nitin from EC. The topic is cell concept of wireless networks. Frequency use. The concept of frequency use is based on assigning to each cell a group of radio channels used within a small geographic area. Cells are assigned a group of channels that is completely different from neighboring cells. The coverage area of cells is called the footprint and is limited by a boundary so that the same group of channels can be used in cells are far enough apart. Cellular system. And of at any time mobile stations MS is in one cell and under the control of base stations. When a mobile station leaves a cell, base station notices weak signal. Base station asks surrounding base stations if they are getting a stronger signal. Base station transfers ownership to one with strongest signal. And MTSO sends new channel to a MS and notifies MS of new pause. And zero-G wireless. Mobile radio telephones were used for military communications in early 20th century. Car-based telephones first introduced in mid-1940s. Single large transmitter on top of a tall building. Single channel used for sending and receiving. To talk, user pushed a button enabled transmission and disabled reception. Become known as push to talk in 1950s. CB radio taxis, police cars use this technology. IMTS, improved mobile telephone systems, introduced in 1960s. Used two channels, one for sending and one for receiving. No need for push to talk. Used 23 channels from 150 MHz to 450 MHz. First generation cellular. Advanced mobile phone service AMPS invented at Bell Labs and first installed in 1982. Used in England called TACS and Japan called MCS-L1. Key ideas: exclusively analog and geographically area divided into cells, typically 10 kilometers to 25 kilometers. Cells are small, frequency reuse exploited in nearby cells as compared to IMTS could use 5 to 10 times more users in same area by using frequency reuse. Smaller cells also require less powerful, cheaper, smaller devices. Alternatives to 3G cellular. Major technical undertaking with many organizational and marketing overtones. Questions about the need for the additional investment for 3G. Wireless LAN local area network in public places such as shopping malls and airports offer options. Other high-speed wireless data solutions compete with 3G. Mobitech's low data rates is used in narrow band as compared to 30 kHz SM and 5 MHz 3G. DOCHIP 40 to 128 kbps data rates flash OFDM 1.5 Mbps up to 3 Mbps. Differences between first and second generation systems. Digital traffic channels first generation systems are almost purely analog. Second generation systems are digital. Encryption. All second generation systems provide encryption to prevent eavesdropping. Error detection and correction. Second generation digital traffic allows for detection and correction, giving clear voice reception. Channel access. Second generation systems allows channels to be dynamically shared by a number of users. Advanced mobile phone system. First generation analog system for North America, 225 MHz bands are allotted to AMPS. Forward down base station to mobile unit and reverse up mobile to base station. In each market, two operators are accommodated. Each operator is allocated only 12.5 MHz in each direction. Channels spaced 30 kHz apart, 114 channels per operator, 21 control paging access, and 395 traffic channels. Each call uses two traffic channels forward equal to reverse plus 45 MHz. Control channels are 10 kbps digital channels. Traffic channels are analog using frequency modulation. Cell design. Cell grouped into a cluster of 7. Letters indicate frequency used. For each frequency, a buffer of two cells is used before reuse. To add more users, smaller cells are used. Frequencies may not need to be different in CDMA soft handoff. Cellular network organization. Cellular network organization. Cell is an around 10-mile radius, served by base station consisting of transmitter, receiver, and control unit. Base station antenna is placed in high places, churches, high-rise buildings. Operators may around $500 per month for base station. 10 to 50 frequencies assigned to each cell. Cells set up such that antennas of all neighbors are equidistant, hexagonal pattern. In North America, 225 MHz bands allocated to AMPs. One for transmission from base to mobile unit, one for transmission from mobile unit to base. Approaches to increase capacity, adding and reassigning channels. Some channels are not used. Frequency borrowing frequency are taken from adjacent cells by congested cells. Cell splitting. Cells in areas of high usage can be split into smaller cells. Microcells. Antennas move to buildings, fields, and lamp posts. Cellular architecture is divided into three parts: mobile station, base station, subsystem, and network system. In mobile station communicates across UM interface, air interface with base station transceiver in same cell as mobile unit. Mobile equipment, physical terminals such as telephone or PCS. Mobile equipment includes radio transceiver, digital signal processors, and subscriber identity module (SIM). GSM subscriber units are generic until SIM is inserted. SIM is ROM, not necessarily the subscriber devices. BSS consists of base station controller and one or more base transceiver stations. BSC reserves radio frequencies, manages handoff of mobile unit from one cell to another within BSS and control paging. Network Subsystem Center. Mobile Switching Center (MSC) is at core consists of several databases. Home location registers database stores information about each subscriber that belongs to it. Visitor location register database maintains information about subscribers currently physically in the region. Authentication Center database used for authentication activities holds inscription keys. An equipment identity register database keeps track of the type of equipment that exists at the mobile station. Thank you.